today are Daniel Gonzalez. Daniel is the Business Development Manager for Optical Transport Measurement Instruments with Anritsu. Daniel has over 19 years experience in digital and optical transport testing, development, training, and execution, spanning technologies including TDM, SONET, OTN, ATM, carrier Ethernet, and physical layer signal integrity. Our other speaker is Craig Staub. Craig is the General Manager of Somerset T&M Solutions and Somerset ATE Solutions, the two test equipment divisions inside Somerset Capital Group. Craig has been with Somerset for 5 years. I would now like to turn it over to Daniel.
Thanks, Tina, and thanks everyone for attending today's presentation. Again, just a brief introduction of myself. As Tina mentioned, I'm the Business Development Manager for Anritsu. I support the optical transport and test equipment, all your field portable devices, everything from OTDRs up to optical transport. And then brief introduction, I'll let Craig introduce himself. Craig, if you please.
Yeah, thank you. My name's Craig Staub. I'm with Somerset Capital Group. Somerset is a leasing capital company based out of Connecticut. And we have our divisions group is in Tempe, Arizona. I run that group where we lease and rent test equipment for various spaces. A large part of it is for portable test equipment from Anritsu, but we also do semiconductor test equipment as well.
Thank you. So during the next 45 minutes, what do you hope to gain from this presentation? Here is what we'd like to cover. So first part of the presentation, we want to really talk about the 5G RAN installation and turn-up requirement, because they are really changing, especially for the contractors as they're completing their projects and submitting closeout packages compared to that of 4G. 5G new test requirements demand field test equipment with new capabilities to support things such as RAN synchronization, as well as your previous requirements like fiber optics and transport. The focus of the presentation is going to be around the Anritsu MT1000, or our Network Master Pro. This is our field tester. This has been approved by the wireless carriers for network synchronization, field testing, installation, turn-up, as well as failover and troubleshooting. So over the next 45 minutes, we're going to focus on that RAN synchronization testing as far as what it looks like and what you need to know what to expect in the field. Before that, I'm going to hand the presentation over to Craig, and he'll give a brief update on what you need to know when it comes to Somerset. So go ahead, Craig.
Thank you, Daniel. So I won't take too much time. I know folks are here to learn about the MT1000 and 5G testing and how to use the new network tester for that application, but did want to just give you an introduction to Somerset. We have purchased a number of MT1000s for our rental pool, and we're available for, short-term rentals and leasing on various Anritsu products. So a quick overview of who Somerset is. I just have 3 slides. I'll promise to keep it quick. So Somerset's actually been around for over 35 years. We're the largest and oldest private leasing company in the U.S., and we lease all sorts of different equipment. We are an equipment company. And we have over 400 customers, 40 different asset classes, and that's everything from forklifts to ground support equipment at airports. And then our group is based out of Tempe, where we do almost exclusively test equipment. We started off as a semiconductor test equipment leasing group and have grown into other various areas. So test and measurement is something we added a few years ago. Anritsu partnership got formed in April as a formal rental and leasing partner. And since then, we have been buying lots of Anritsu portable gear for rental and for leasing. Thank you, Daniel. So if you look in terms of how we work with Anritsu, there is some equipment that we keep on our shelf that's available for immediate rental. And that could be as short as, a month or up to 12 months. For the equipment we keep on our shelf, that means we could ship immediately. So if folks have a project they didn't see that they needed equipment for, That's something we can spin very quickly. It also means we're very flexible on the amount of time you have it for, and the cost will be attractive. Our stocking center is in Arizona, but we can ship anywhere in the U.S. But if you do have an office that's in the Southwest, we do have a lot of customers that like to come to our facility to pick up directly, and that saves people on shipping the equipment back and forth, which frankly could sometimes be as much as the rental itself. We do also have other equipment that folks might need that's complementary to the Anritsu gear, things like splicers and antenna aligners, maybe PIM tape if you're working on a PIM project. And then for the stuff that we don't necessarily carry in our rental pool, Somerset is inherently and has been for over 30 years a leasing company. And so anything we don't necessarily keep on hand, we would absolutely be willing to do an operating lease or a finance lease. We can do things like, if you want to own it, then take either divide by 12 or divide by 24. So you spread your payments out and don't have to use up all your cash at the beginning. The other thing, real quick, Daniel, on the previous slide, in terms of short-term rentals, we do offer programs where you're not sure you want to own for now, but you may want to own in the future. We offer equity towards purchase. So you're paying us rent because it's a short-term project, and then it turns out it might be something you want to own. We can take a portion of those rental dollars spent and apply it towards the purchase. Thank you, Daniel. And then we'll finish up on this slide. On the left side is what we carry today for rental. Again, we're adding to this. If folks have things that you'd like us to carry, we're more than happy to go spend the money with Anritsu to go put it on our shelves. And then there's some contact information. So our website, Glenn is our sales manager. Please feel free to email and call Glenn, bother him, tell him what you need, and we're here to solve problems. For the MT1000, we have a number of them on order. We have 5 that are coming in this week, and we're ready to ship and deliver.
Thank you, Craig. So
thanks, Daniel.
Let's break this presentation down into about 3 different sections. We're going to start off with 5G RAN timing and synchronization, because again, this is very new for those of you that are doing the installation and deployment of what that 5G RAN looks like now, especially when it comes to the timing. Then we're going to go into the actual timing mechanism that's being used for 5G. It's called Precision Time Protocol, or PTP for short. Briefly talk about what it is, why should you care, and then going into the last section, how do you test for this new 5G RAN network timing? Again, this is very new for a lot of our contractor base who has to support this moving forward. So we just wanted to let you know what to look out for and how to prepare for it, and as well as you're bidding for these new contracts, what you need to take into consideration when you submit those bids. So for this first section, let's talk about what is that network timing and the synchronization impacts for 5G. Then we'll go into why is that timing changed from 4G to 5G, just to give you a little background. What happens when this timing doesn't work, and what the operators are going to see if this isn't deployed correctly. And then the timing method that's being used. So this is kind of our little public service announcement. So let's take a brief example here. You see a stadium on the left, and you see various types of 5G deployment, be millimeter wave, this could be DAS, this could be a variety of different macro or micro cells, urban environment. And what you'll notice is that the timing for these, instead of coming from GPS at the sites, it's actually coming from these grandmaster clocks on the right. This enables 5G synchronization to do all the cool things that you hear about 5G, beamforming, the high throughput, coordinated multi-point. And what it's doing is it's actually sending what's called these timing packets through the network. So instead of that timing coming over the air from your GPS, those timing is being sent through these Ethernet packets through your CRAN, through your routers, over the fiber, and eventually to the various base stations. Now with all providers, they also have backup put in place. So you have multiple grandmaster clocks on the right. In case one fails, as you see in this picture, another one picks up and it sends that timing through the boundary clock. The question becomes, what happens if this isn't provisioned correctly? Or what happens if the timing is out of sync? Well, what happens is if this happens, everything that's connected to that boundary clock all loses its synchronization, not just one site. So as you can imagine, if you have a router that's plugged into multiple sites all over your fiber backhaul or your fiber fronthaul, and in the event that boundary clock loses that timing, well, it affects everybody connected to it. So that's a very big difference compared to that of 4G. So why are we even changing the timing from 4G to 5G? Well, what you're going to notice is, especially when it comes to the high deployment of 5G radios, so for those of you that are involved in small cell deployment and millimeter wave deployment, it costs a lot of money to add a GPS to every one of those millimeter sites. Then you also have to think about clear sky visibility. What happens when you're deploying these new street level deployments where these street level cells are being deployed on lamp posts and light fixtures in the middle of a city environment between buildings? Well, ideally, when this is working correctly, you're going to see that timing is going to be requiring both phase and time synchronization. Why is that? Well, because again, in order to take advantage of these things, you're going to have synchronization such as a coordinated multi-point, your increased OTDOA or time difference of arrival. All of these things work great unless you lose that synchronization. In the event that you lose that phase synchronization, not only do you lose synchronization from that individual site, but when you have these overlapping sites, they're no longer able to communicate with each other. And this causes a significant amount of what you would traditionally call interference, but not the interference you're used to. This is synchronization interference, or due to interference, or due to synchronization. So what happens when that 5G time division duplexing, or TDD, is out of phase sync? Well, per the standards, as long as you're within 1.5 microseconds from your reference clock to your sites, and then each one of your sites are within 3 microseconds of alignment, everything works great. Here's a picture of what that looks like. So when you're looking at between that of a cell site on the left and your phone or your handheld device on the right, as long as they're within synchronized of one another, you see the uplink and the downlink are in relation to each other. But notice on the left, if you're not in synchronization, so you do not have the same frequency and time synchronization, you'll notice that it's no longer aligned. They're on different times. And as a result, your device might think you're on the uplink, where your site thinks you're on the downlink. That turns into your loss of synchronization, ultimately turning into interference or loss of that site. So this is why with 5G, they're transitioning away from, again, having GPS deployed at every site. And they're starting to add this new PTP network, or timing through your network, to verify you don't lose that synchronization that you saw in the previous example. This ends up, again, starting on the right-hand side with the grandmaster clock that's generating those timing messages, and those timing messages are going through your fiber network. And ultimately, those are going through your base stations and to your radios themselves. That's what's providing the timing through Ethernet packets over your fiber network. So now that we talked a little bit about why 5G requires this new timing, let's talk about what that timing looks like, because there's a couple of different deployments of this. We'll also talk about the type of equipment that you're going to see that's out there that you would be connecting to in order to provide that timing. Then we'll go into some of the failures. What can you expect if this isn't deployed correctly? And how can you test that ultimately to verify that you will not have these failures in the field? Well, first, you have two different types of timing profiles. The first is partial timing support. You started seeing this in the initial deployment of 5G, which started back in last year. And what's interesting about this is that you'll notice that in the diagram on the right, you still have your grandmaster, that's all the way on the right. You have your boundary clocks in the middle, but then you also have non-PTP equipment. These could be your routers and your switches that were already deployed in your CRAN. What's important to note about this is that even though you have timing going through your network, it's mostly serving as a backup because you still had GPS deployed at the site. That's where you see the GPS antenna at both, or the GPS satellites at both the Grandmaster and then the site. Now, moving forward, in the second rollout of 5G that we're starting to see this year, and it's going to roll into next year, they're switching over from partial timing support to full timing support. Now, here's the difference. You'll notice compared to the top and the bottom doesn't have any non-PTP equipment. Every network element, the routers, the switches, all of them have to be PTP aware. So they all have to be turned on to support this full timing support. In addition, you notice that there is no GPS at the site, which is all the way on the left-hand side, compared to the top where it was the GPS antenna was serving as the primary. On the bottom, you no longer see that GPS at the site itself. As in the name describes, full timing support means all of the timing is going through the network, no longer GPS at the site. So what does this look like in the field? What is the equipment that's involved? Well, I'm showing two different types of deployments. Now you may see different types of equipment here, depending on the carrier that you're working with or the sites that you're testing at. But here's just one example. You see here on the top, your Grandmaster clock is a microchip or microsemi TP4100. Microsemi or microchip creates the Grandmaster clocks that are being deployed at the various CRANs in order to provide that timing through the network. Then you see a series of routers. In this case, you see a series of Nokia routers as an example, going from the service access switch, the 7210 in the middle, going down to the 7250 on the bottom. Now, the important one to note is the one on the bottom, because that's where the test equipment's connecting to. This is the last router, the 7250, before connecting to your baseband unit at the site. So if you are testing the baseband or the connectivity to the baseband unit, that fiber is coming from that router on the bottom. That's where you'd be connecting that fiber to on the tester. A second deployment, very similar to the previous, uses ADVA or the 5420 Edge Grandmaster that you see on top. And again, these are all connected with fiber going to the Cisco routers instead of Nokia. You see the Cisco 5501 in the middle, the Cisco NCS 540 on the bottom. Now again, similar to the previous slide where it showed the IXR on the bottom being that last point before the route or before the cell site, this is the same where the 540 router could either be deployed in the CRAN or it could be all the way at the cell site itself. That's where the timing's coming from that's feeding the various radio units or baseband units. What does the PTP sync failures look like? Well, I have 4 different examples here. I'm not going to go into too much detail, but just to give you an idea, these are 4 common problems that we've seen in the field when deploying 5G network timing. Starting with the top left, it had to do with the Edge Grandmaster having the incorrect antenna delay value. That antenna delay caused incorrect timing going through the network because that antenna delay wasn't taken into account. On the right, top right, you see the max timing error. And I'll go a little bit more into detail later on this one, but this is the measurement that's taken on the tester. And this is basically telling you whether or not you have too much timing error. That could be a result of too many boundary clocks. That could be a result of buffering within the network. That could be a result of issues with the baseband unit. This is where you would determine whether or not you are achieving or exceeding your maximum timing budget. The bottom left shows possible incorrect provisioning within the Cisco or Nokia routers. So this is what happens when the routers are not provisioned correctly, and as a result, missing commands, such as the one shown in red, would show a failure in the timing. And then the bottom right shows incorrect grandmaster clock status failover. You'd see this in the event that, again, this is a measurement taken on the tester in case that the provisioning of the actual edge clocks were not provisioned correctly, resulting in incorrect grandmaster clock failover. Now, from an operator's perspective, what's their biggest fear is which one of these actually generate alarms on the network? Well, the truth is, out of the 4 examples that I showed in the previous slide, the only one that actually generates operator network failures is the max timing error. That's why this measurement that you see on the top right is so critical during installation. And you're going to see operators demanding this measurement being taken at the sites during network deployment, during the installation of the new radios or baseband units to verify they do not exceed this measurement. If this measurement is not taken, it will generate alarms on the system. The measurement, the issues on the left, the incorrect edge grandmaster settings, the boundary clock provisioning, and the grandmaster clock ID can all go unnoticed if the one on the right is not taken. So going back to that example we showed in the beginning of the presentation, what happens when these network syncs go and issues go unchecked? Well, again, here's the example again. You have the grandmaster clock on the right, as we talked about, ADVA or microsemi. You got the boundary clocks in the middle. This could be Nokia, it could be Cisco, but it could be other vendors as well. And you got the timing going through those routers over the fiber to the 5G sites that are being deployed. In the event of a failover, a backup clock takes over. And again, those base stations still maintain their timing because this has all been tested. If these individual sites were not tested and you didn't verify that the timing was being received from the boundary clock may be provisioned incorrectly, or you could have various issues that I described before, resulting in complete failure of all of the sites that are connected to those boundary clocks. Now, the one thing to add to this is you could have multiple sites connected to boundary clocks. And in some cases, you could see outages in the excess of over 200 5G sites all losing their timing as a result of this measurement not taking place in the field. This is why this measurement, this 5G network sync measurement, has become so critical in the deployment of 5G sites. So next point here, where does and when does this testing take place? Then we'll go into what groups, and then finally we go into the actual timing. So first, where and when does this testing takes place? Well, you see basically a diagram again on the right, top right-hand side. You got your edge grandmasters going through your various cell site service routers and then your cell site aggregators. Ideally, you want to take this measurement during failover scenarios. This is what happens in the event that there's a failover, forcing the routers or the sites to switch their paths to determine whether or not their failover, their backup timing, is still working correctly. We've seen this testing done in 3 different times. First of which, during the initial turnup. This is where we see a lot of contractors that are involved, as well as network operator teams that are going out to the sites, verifying during turnup that their timing is working correctly. We also see this during troubleshooting. In the event that there is an issue during the timing, how can we, if there is an issue with the timing, being able to troubleshoot at each one of those routers where that timing problem is taking place. And then finally, we're seeing this for birth certificates. So very similar to site turnup, most contractor teams are being responsible for providing a birth certificate, otherwise a closeout package, showing that this network sync timing has been verified at the time of install. So a closeout package. How do you perform this testing? So as we mentioned earlier in the presentation, the Anritsu MT1000 is a field portable optical and transport test solution. This has been approved by providers and is being used by both contractor teams and providers in order to verify that optical timing and testing or network synchronization testing at the point of install. The tester is broken up into several different modules that you see on the bottom right-hand corner. And what's important to note here is it's not just a timing tester. We've just talked about timing in this presentation, but in reality, it supports all of the various timing and 5G requirements. So you see in the box on the bottom right, on the bottom left, you have your built-in atomic clock. That rubidium clock's required to do the timing measurement, but you also have your Ethernet, your eCPRI, and your radio over Ethernet transport. So when you're testing your eCPRI or CPRI from the radios to your BBU, this supports that testing over fiber. You also have your optical testing with your OTDR, so your optical loss measurements. You have your fiber testing, your OTDR measurements, all built into that same unit. And then you have your various optical interfaces, so your SFPs, your SFP Plus, the new optics that you're seeing for 5G. And for those of you that have been doing the installs, you've seen the optics change. They're no longer just 10 gig SFPs. You're seeing 25 gigs, and in some case, 100 gig interfaces over QSFP28. Those are the pluggable optics now that support 100 gig. Those are all supported in the same tester. So all of your previous 4G and 5G requirements, everything from your fiber testing, your SFP testing, your CPRI testing, are all included in this package, as well as the new 5G requirements, such as the RAN synchronization that we just talked about. So with that, I'm going to hand the presentation back to Tina, and we'll be able to field any questions that you may have. So if anyone has any questions, feel free to submit any questions on the Q&A tab, and both Craig and I would be happy to address any of these questions.
Thank you, Danny. There are about 3 or 4 in the questions pane. So I'll read them if you can't see them. One is, what is Somerset's typical turnaround time?
Yeah, I can field that. Thank you. First of all, thanks again to Enritsu for setting this up and for all those attending. I mentioned we got some MT1000s in stock that we're getting in stock this week, so we can ship those quickly. There is some time to get folks set up as a rental or leasing customer. So the first step of that is doing a credit check, and we can typically do a turnaround time on that in 24 hours. One thing that folks may want to do if you think there might be a rental coming up in the future, is go ahead and work with Glenn to get us set up in your system and you set up in our system and do a credit check ahead of time. And then when the need for the equipment arises for the project, then we can, quote, get a PO and ship same day or next day. Hope that answers the question.
Yes, thank you. Who will be responsible for performing the new 5G network sync tests in the field?
Thanks, Tina. I'll field that question. We're seeing this done primarily in 2 different stages. In the first stage, we're seeing a lot of the operators initially do the testing within their own organization. So the field teams responsible for the various operators are doing the initial deployment at 5G sites. However, in the second phase, we're seeing a lot of this being subcontracted out. Many of the local markets that are, and again, these are per operator, are reaching out to their subcontractor teams that they have relationships with to do the installation of these 5G sites and perform the network synchronization test as part of their closeout package. So it depends on which operator that you're working with, and it also depends on the phase in which that operator is in. But we're seeing a combination of the two, either the operators' individual network field teams, or we're seeing this subcontracted by various general contractors that are certified with that operator to perform 5G installations and include this network synchronization testing as part of it.
Thank you. Are these long tests in the field?
All right, that's also a good question. I'll take care of that one as well. So there are a couple of things that you're going to have to take into consideration when you're doing these tests in the field. First of which, it consists of primarily 2 tests. The first test is a very fast 5-minute test. It consists of the Anritsu MT1000 Network Master Pro, and it's an automated test that basically shows whether or not the PTP, that the site that they're connected to is receiving PTP timing. It's able to see the grandmaster clock, the edge grandmaster that it's speaking to, and that it's able to negotiate that timing. So it's basically a turn-up test. 5 minutes, yes, I see the timing, and it is working correctly. The second test is a longer test. That one is a 45-minute test, and that's the one that's actually measuring the timing error. So after you verify that the timing is working correctly, the 5-minute turn-up test, the 45-minute test is used only when you are required to determine what the timing error is. In most turn-up cases, you only need to do the 5-minute test. In the cases where you have to verify the timing performance and that timing error, that test is 45 minutes. And just to give you an idea of what that test looks like, let me bring up the tester here. I'm actually remote controlling an MT1000, and this is kind of a sample of what that automated test looks like. This is the 5-minute test, and once you start the test, hitting the icon on the top right-hand side here, it's going to execute the test, and you're going to get a running history of the test as it's performing. So the important points I want to point out here, you'll see in green is what the field, either the contractor or that of the operations engineer, this is what they're most important at looking at. They want to see the part in green. It's going to tell you whether or not you're receiving your PTP packets over your fiber, and it's going to tell you if it sees the correct edge grandmaster. And it tells you there in the green, the EGM is set for primary priority, and it tells you all the details you need to know about your edge grandmaster. Now, again, this is all included in the automated report. The tester creates the closeout package and provides that report, and that would be what the contractor would be submitting to the provider as part of their closeout package, would be this information. So sorry, kind of a long answer, but I did want to point out that there are 2 tests, a very short test that would be done during the turn up and installation, and then a longer test if a performance measurement is required.
Thank you, Danny. I don't have any other questions. So just give everyone a minute. Does anyone, if you have any questions, please write them in. Otherwise, thank you so much, Danny and Craig, for today's presentation.
Our pleasure. Thank you very much. If you have any further questions, please feel free to reach out to either myself or Anritsu, as well as Craig and Glenn with Somerset, and we'd be happy to support you guys.
Thank you very much. This will conclude the presentation. Goodbye, everyone.